Windows 10 computers have two names. Host names, which are 255 character names, for example, scribbler.pearson.com. NetBIOS names, these are 16 character names, for example, scribbler and then in square brackets 20 to indicate the service that we're talking about. NetBIOS names are less frequently used now. It's a legacy protocol used for certain applications, perhaps back in the 1990s. These days it's fully qualified domain names or host names that you'll see most of the time. When you attempt to resolve a name into an IP address, here's how it might work. The first thing that the local computer does is check to see if the name being queried is its own name, i.e. the local host name. Assuming that it's not, it checks the contents of the hosts file. This is a text file that resides in the System32 folder in Windows. It then will check in the DNS resolver cache to see if this is a name that's been recently resolved. Generally, names such as host names that have been resolved by a DNS server are cached for an hour. That cached time limit is configurable on the server rather than on the client. If this is not the local host name and it's not present in the host file and it's not in the DNS resolver cache, then the host will query a DNS server. For both IP4 and IP6, use the following procedure to configure DNS settings on the client. First, open Network and Sharing Center, select Change Adapter Settings, right-click the appropriate network adapter and then click Properties. Double-click either IP4 or IP6 as appropriate, and then click Use the following DNS server address, and then enter a valid IP4 or IP6 address. You can also use the DNS settings, or configure rather the DNS settings by using the netshish command. Netshish interface IP set DNS, and then the name of the network interface, and then a static IP address for a DNS server. You can additionally use the Windows PowerShell set DNS client server address commandlet. You can also look at the advanced DNS properties on the Advanced TCP/IP Settings dialog box. This is shown here in the graphic. I'm going to talk about this in the demonstration, but I'll go through it very briefly now. You can append primary and connection-specific DNS suffixes. What is a suffix? A suffix is something like pearson.com to which you apply, or that you apply to a client name like Scribbler. So scribbler.pearson.com. Pearson.com is one of the suffixes. It may be that you want to apply multiple suffixes to a given computer. Perhaps it's in an organizational unit called education.pearson.com, but it's in a domain called pearson.com. You might decide therefore to add an additional suffix. Pearson.com might be its primary suffix, and education.pearson.com might be an additional suffix, and you can configure that behavior here. You can also determine how suffixes are applied when a query is being performed. Many people omit to enter the fully qualified domain name when they enter a path, so they try to connect to a server called www instead of entering the full path name. And what's Windows going to do about that? Well, you can configure that here. What it will do is apply the primary suffix and any connection-specific suffixes, and then it will apply the parent suffixes. And again, I'm going to talk about that in the demonstration. As you see, you can specify the particular order in which these suffixes are applied. You can also define additional suffixes for a particular network connection. Most suffixes that we'll use are going to be the primary suffix, which is configured as a property of the computer. You'll see how to do that in the demonstration. But you can specify additional suffixes for specific network connections. So if you have multiple network adapters, maybe you've got a VPN as well, each of those could be given a different suffix for whatever reason. If you want, if you're using multiple suffixes, you can choose to register that connection in DNS so that people can find this computer by using that configured address. Let's take a look at how you can configure DNS client settings in the demonstration. Okay, perhaps the best place to start when talking about DNS is on the server. So this is a Windows Server 2016 server computer. It's installed, as you can see in Server Manager here, with Active Directory, so it's a domain controller. It is also using DHCP, and it's providing DNS as well as file and storage services. So to configure DNS, let's take a look into Tools, and select the DNS Manager. The server name is listed up here, that's the local server. And then we have things broken down into forward and reverse lookup zones and conditional forwarders. Probably outside the scope of the course to get into conditional forwarding, but let's just say that it's a means for referring queries, queries from client computers or other servers, down a particular path. Okay. Forward lookup zones are other things you probably need to concern yourself with most. You can see one here called Pearson.com. That happens to match the domain name that we're using in Active Directory, which is fairly logical. And then beneath that we have some Active Directory specific elements, sites, TCP, UDP, all with an underscore prefix. We don't need to worry too much about that either. But we do have some information in the Pearson.com zone. Zone is the term we use to describe an element of the DNS namespace stored on the server somewhere. A forward lookup zone is one which takes a name and converts it into an IP address. So unsurprisingly, within this zone, we can see a server called DC. It's got a type of host A, so it's a host record, and a data element of 172.16.0.10. In other words, if I were to query for the host dc.pearson.com, I would get returned the address 172.16.0.10. There are some other records here which I don't want you to concern yourself with too much. That's getting a bit advanced. But for every host out on the network, you should see a corresponding record listed here. Back over on Windows 10 on the client computer, we can configure the client-side DNS settings. You can do that through Change Adapter Settings, bring up the properties of the network adapter, and in this instance, open up the IP4 protocol. We saw some of these pages earlier on. We can specify one or more DNS server addresses here. So we can use a particular manually assigned address, 172.16.0.222, for example. Specify a subnet mask, a default gateway for communications outside the local subnet. And then one or more servers that we want to use for name resolution. As I mentioned in the last demonstration, you can use the advanced page to configure some advanced DNS properties. Here we see the DNS server address to use. If we've got several, we can list them and we can shuffle the order. Now for most situations, 2 is sufficient. You'll remember I mentioned in a previous demonstration about the primary and connection specific suffixes. Let's deal with that. When a computer belongs to a domain, its primary suffix is the domain name. So for example, if this computer called CL was added to the Pearson.com domain, then it would have a suffix of Pearson.com as its primary suffix. You can apply additional suffixes if you wish. So for example, the computer might be cited in education.pearson.com, which is not a separate Active Directory domain, but is a DNS zone. So you could configure a situation where its primary suffix differed from one of its other DNS suffixes. It's quite an advanced concept, I suppose. But this is where you would specify in which order that would apply. Now this is relevant when a client wants to perform a query, because it needs to know which zone it sits in. If you query, or your application queries for a server called www and you don't provide any additional information, how do we know where that server is? Well, we assume it's in the primary suffix, so we append the primary and then connection specific suffixes. So the primary suffix would be Pearson.com. So if you say, take me to the server www and don't say where it is, it will assume it's www.pearson.com. If that doesn't yield up a valid result, then it will append the additional suffixes listed here. It will also try the parent suffixes in order. So for example, the parent suffix of Pearson.com is .com, and the parent suffix of .com is .. So it will go up the DNS hierarchy to try to resolve www. I won't configure anything here, but that's how it works. It's also important when you troubleshoot to use the complete, fully qualified domain name. So if you want to test name resolution, don't test www, test www.pearson.com to give it its full and complete FQDN. The DNS suffix for a connection can be different than for its primary suffix, so it's perfectly possible for you to have several network adapters, and you might choose that one network adapter is connected to the education.pearson.com DNS zone, in which case you'd configure that suffix accordingly here. Otherwise, you might just use the primary suffix. The primary suffix is not configured here. The primary suffix is configured on the computer's properties. I'll show you that in a moment. You will always want to register this connection address in DNS, and you will also want to use this connection's DNS suffix in DNS registration. Possibly less likely, but it is possible, and this is where you enable it. So if I wanted to enable education.pearson.com as a suffix, I could be sure that would be registered on the DNS server for me. I'll leave that blank for now. It's only going to confuse matters. So I'm just going to click OK to that. And then I'm going to open up a command prompt just to verify the settings. I'll use an elevated prompt. Some of the commands require that, some don't. ipconfig/all displays the full information about the IP configuration, including the DNS servers down the bottom here. If I type ipconfig/display DNS, we can see whether or not there is any resolver cache. Resolver cache is generated when a query has been successfully resolved. So if we were to perform that query for www.pearson.com, if a successful result was returned, we would cache that for a period of time, typically an hour, but that's configurable on the DNS server. And that will be displayed here. So let's perform a quick test. If I send a series of ICMP packets by using ping to the domain controller, we get a reply 172.16.0.10, and it tells us a bit of information. And bear in mind, by the way, if you attempt to use ping and it's unsuccessful, that doesn't necessarily mean that the server you've tried to ping is not online. Quite often, server administrators disable through a firewall the use of ICMP echo packets that are used by ping for testing purposes. Anyway, if we now use ipconfig/display DNS, you can see we now have a record, dc.pearson.com. The time to live is 3574. It's a period of time that's configurable on the server, if you remember, and that this is the answer that we received. If you want to test DNS, you can use a program called nslookup from the command prompt, and then you enter the query that you want to test, and then it will attempt to resolve that. We've got a bit of a timeout there, but not to worry. That's because I didn't form the name correctly. It should have ended in a full stop, and then we've got a result here. There are some command switches you can use with nslookup, notably -D1 and -D2, which provide us with some additional debugging information, but again we'll look at that in a troubleshooting session later. So I mentioned the primary DNS suffix. Let's just take a look at where that's configured. I'll just open up the properties of this PC. Now this computer is in a work group at the moment. As you can see, it's called CL1 and it's in a work group, so it doesn't have a fully qualified domain name yet. Let's go to Advanced System Settings and click the Computer Name tab. And if I click Change and then More, you can see here the primary DNS suffix of this computer can be configured. You'll notice there is a checkbox, Change Primary DNS Suffix when domain membership changes. So by default, if I add this computer to pearson.com, the domain, it will update the primary suffix to be pearson.com. So the two tend to be the same. But as this computer is a workgroup computer, not part of the domain at the moment, those are potentially separate. So we could have an entirely different primary suffix from a domain membership. I'm not going to reconfigure that now. I will do that when we look at adding computers to domains. In the demonstration, you saw how to configure DNS settings for a client computer. We also talked a little bit about DNS zones.